Probability distributions. In this video we're going to take a look at all the concepts required to answer a typical IB probability distribution question. Here we have a typical question. A discrete random variable x has the following probability distribution. The first thing we're going to do is totally dissect this question. These sort of questions can quite easily confuse IB students. The first word, discrete random variable x. Well, a discrete random variable is a variable such as scores in a test. Here we have a table with the top line little x, which can be 0, 1, 2, 3, 4 and 5. So our random variable little x in this case could be scores in a test. There could have been 5 questions, 1 mark per question, and a student could get a score of 0, a score of 1, a score of 2, a score of 3, a score of 4 or a score of 5. The second row in the table, the probability that big X is equal to little x. That is the probability that a student picked at random obtains one of those scores. So the probability that a student picked at random gets a score of 2 is 0.1. The probability that a student picked at random gets a score of 5 is 0.2. The first thing you need to realise is that the sum of the probability that x equals little x must equal 1. The sum of all the probabilities must come to 1. The student is going to get a score of either 0, 1, 2, 3, 4 or 5. In our case, 0.1 plus 0.1 plus 0.1 plus 0.3 plus 0.2 plus 0.2 equals 1. A typical question that a student might be asked is given a table with one of the probabilities missing. The student, it might be called P or Q, and the student is asked to find P or Q. Well, the student knows that the sum of all the probabilities must equal 1, so the student is then able to find what P or Q is equal to. Another typical question is to be asked to find the expected value. And the expected value is another way of asking what is the average, what is the mean. But what do we mean by the expected value? Well, what they're looking for is if you chose a student at random who had done this test, what score would you expect them to get? This is not symmetrical, so you wouldn't expect them to get halfway between 2 and 3, because if you look at the tables, there is a higher probability that a student gets 3, 4 or 5 than there is that a student gets 0, 1 or 2. You will always be able to find the expected value formula in the formula booklet. So the expected value of a discrete random variable x is equal to the sum of x times the probability that big X equals little x. So to find the expected value in this case, the expected value of x in this case is equal to 0 times 0.1 plus 1 times 0.1 plus 2 times 0.1 plus 3 times 0.3 plus 4 times 0.2 plus 5 times 0.2. So the expected value in this case is equal to 3. So if you chose one student at random, you would expect them to have scored 3. A typical IB question might be as follows. The probability distribution of a discrete random variable x is given by the following table, where n and p are constants. 1a. Find the value of p. We know that all the probabilities must add up to 1. So therefore, p is equal to 1 minus a half minus a fifth minus a fifth. Therefore, p is equal to 1/10. Part B. Given that the expected value of x is equal to 10, find the value of n. We start with our formula. We know that the expected value of x is equal to the sum of x times p of x equals x. And in this case, we know that it's equal to 10. Therefore, 1 times a half plus 5 times a fifth plus 10 times a fifth plus n times 1/10, because p is 1/10, is equal to 10. Therefore, 3.5 plus n over 10 is equal to 10. Therefore, n is equal to 65. Another typical IB question might be as follows. A biased four-sided die is rolled. The following table gives the probability of each score. A. Find the value of k. We know that the probabilities must add up to 1. Therefore, k is equal to 1 minus 0.28 minus 0.15 minus 0.3. Therefore, k is equal to 0.27. B. Calculate the expected value of the score. We know that the expected value of x is equal to the sum of x times the probability that x equals x. Therefore, the expected value of x is equal to 1 times 0.28 plus 2 times 0.27 plus 3 times 0.15 plus 4 times 0.3. Therefore, the expected value of x is equal to 2.47, to 3 significant figures. Part C. The die is rolled 80 times. on how many rolls would you expect to obtain a 3? Well, the probability that x is equal to 3 is equal to 0.15. Therefore, if it's rolled 80 times, you would expect to get 80 times 0.15. Therefore, you would expect to get a 3 on 12 occasions.